Hi everyone, today we're going to do factoring and we will factor difference of two squares, and this is the form x squared minus y squared. Let us make a review for special product. When we multiply x plus y times x minus y, the answer is a binomial x squared minus y squared. The factors are called conjugates. It means the conjugate of x plus y is the x minus y, and vice versa. While the product, we call this difference of two squares. For today's lesson, we are going to do the reverse process. The problem will come to you as this product, and then you are required to give the factors of this form. How to factor difference of two squares? In step 1, rewrite the two terms as squares of some terms. Step 2, write the factors following the pattern. The x squared minus y squared equals the binomial x plus y times x minus y. Let us have example 1. Factor the binomial x squared minus 9. For step 1, we will rewrite the two terms as squares of some terms. So the x squared is now written as the square of x, and then minus the 9 is now 3 squared. For step 2, we're going to follow this pattern. It means we expect two binomials in our answer. But take note that the signs must be different. One is positive, the other is negative. We're going to put x on the first blank of the binomials. And then the 3 will be the second term of each of the binomial. So we see here we have the x plus 3 times the x minus 3. So this is our answer. Let us have example 2. Factor 64y squared minus 1. Again, we're going to rewrite these two terms into squares of some terms. The 64y squared can be written as the square of 8y, and then minus the 1, we can write it also as the square of 1. And then for our answer, there will be two binomials. In the first term, it will be 8y, also 8y in the first term of the second binomial. And for the signs, it must be opposite. One is minus, the other is plus. In our answer here, the negative comes first, followed by positive. And it doesn't matter as long as the signs are different. Now for the second term, we copy that 1. So it's now placed here and also in here. So our answer is the binomial 8y minus 1 times 8y plus 1. This is our final answer. Let us consider example 3. Factor the binomial 48x raised to 4 y squared minus 75 y square. The terms are not perfect squares. We can see here that the variables are perfect squares. However, the coefficients are not. Therefore, these two terms are not perfect squares. But remember, we can check for greatest common factor of each term. I found out that the GCF is 3y squared. So if I pull out that greatest common factor, this first term here will become 16x raised to 4, while the 75y squared will be 25. Of course, the negative sign we will just copy here. So for our problem here now, we have monomial times binomial. And then we will check if this binomial here have terms which are perfect squares. The 16x raised to 4, we can write this as the square of 4x squared, and then minus. We know that 25 is a perfect square number, so that is 5 squared. And then we will just copy that 3y squared down here. And then we will have the step 2. For step 2, we are now expecting two binomials here. The first term will be the 4x squared. It's now here and also here. And then for the signs, we will have the plus and minus. And for the second term of the binomials respectively, it will be this number 5. It's now here and also here. So our final answer is this 3y squared times the binomial 4x squared plus 5 times the binomial 4x squared minus 5. And this is our final answer. I hope you learned something from this video. See you again next time.